Hey guys, welcome back to part number 2 of this flows playlist, in which I will actually dive deeper into flow operators. So what that actually is, you will learn that in this video. And as usual, I will start very simple here, and then I will slowly increase the complexity. And at the end of this video, what we will cover there will be quite complex and difficult to understand, but I will actually try my best to explain it as easy as I can. So what is actually a flow operator? In the end, that is just something that decides how, or actually what happens with an emission of a flow. So in the recent video, we actually built this very simple countdown timer here in form of a flow, and we then just collected that. So with every single emission, with every single second, we actually just collect that and print that in our console. However, there is a lot more we can actually do with flows. We cannot only just collect these, we can also apply these so-called operators to actually transform our emissions. For example, it is not only to transform emissions, but that is one part of flow operators, and I will show you the ones that are actually the most used. There are some more. I won't be able to cover all of the flow operators here, but I will show you all of these that I just regularly need in my projects. So let's actually switch back to the normal collect block here to actually get all emissions. And I will also remove the delay here because we don't need this. And then let's actually apply a flow operator. So a very simple one would just be filter. You might already know that from lists, and that's just useful to filter our flow. So we now get our time value or emission, and we now need to return a Boolean expression here if we want to actually filter this out or not. So if this is true, we will forward it to collect, and if not, we will just throw it away. So we could say if time modulo 2 is equal to 0, so we actually only want to receive even values. That's what that would mean. So if we now launch this app and actually go to logcat, and we see the current time is 10, 8. So now we actually only get even values because we filter these values with this Boolean expression. So that is one thing you can do with flows, which is very, very easy. And the cool thing is you can chain these operators as much as you like, so that will again also just return a flow. Otherwise we wouldn't be able to call collect on that. So we can also take a look at, for example, map, which you also might know from lists already. What map will do is, well, it will actually take the time value, which is, by the way, now the filtered value, because we put this filter function in between. We can now use that to map it to a new value. So we could say time times time. So we just, whatever value we get in here, if it's 2, we will map it to 4. If it's 3, we will map it to 9. And then we will collect these values. So if we now relaunch this and take a look, then we see the current time is 100, 64, 36, and so on. So we now first filter these. We only get even values, and then we simply square these even values and collect them. And one more very simple flow operator we have here is actually called onEach. And that doesn't really transform our values. Instead, it just does something with these. So in case you just want to print your values, you can do that in here. So print line time. And you can say, yeah, time here is pretty much like collect, just that you can also chain that with other flow operators. So that will return a flow, while collect will return nothing. So with collect, we actually really collect the flow and finish. So just make sure that it's finished. But onEach returns a flow, and it won't really finish off the flow here. By the way, you could also use onEach to launch that flow in a little different way without this coroutine scope.launch. Instead, we could also just say countdown flow. Let's say .onEach. We print the value. And then we could say that launch in viewModelScope. So that would be equivalent to doing countdown flow dot collect inside of a coroutine scope here. So those are really the few flow operators I need in almost every project. Those are super often used, and those are also very simple. Like, I don't think it's really hard to understand what these do. let's actually get to another type of flow operators. And those are so-called terminal flow operators. So why is it called terminal? Well, because these terminate the flow. So these basically take the whole results of a flow, all emissions together, and then do something with these. So let's take a look here. Instead of collect, we could also finish this off with a so-called terminal operator. So we could say, for example, count, which I think is the easiest one. So what that will do is it will actually count the values that match a specific condition. So if we want to say, okay, let's say modulo 2 is equal to 0 again. So it will first filter these, then it will map these, print these, and then it will take a look if the emission is actually an even number, it will count these. And it will actually return that as an integer value. So val count is equal to this. You can see that's an integer. And then after that, we could simply print this and say the count is count. And if we now launch this and take a look at here, say the count is, of course the flow needs to finish first, which takes 10 seconds here, I think. Yeah, should take 10 seconds. And then it says the count is 6. So there are 6 numbers that were actually divisible by 2. So that were actually even numbers. And of course, it now considers that we actually filtered and mapped these first. So it will take these emissions and not the direct emissions of our count on flow. So if we don't have these, then it would look differently again. However, let's take a look at a different terminal flow operator, and you might also already know that from lists, which is called reduce. And that will also actually return an integer here in our case, because yeah, our flow also emits integer values. And this, on the one hand, has a so-called accumulator and a value. So we now get 2 values in here. What's the reason for that? Well, reduce, let's actually call that reduce result or so. Reduce will now be executed for every single emission. The accumulator is actually, it's a little bit hard to explain, but let's first actually return something here, and then it will be easier to understand that. So we could say accumulator plus value, and what reduce would now do in this case is it would be executed for the very first 2 emissions, so which would be 10 and 9 here. It would add these, so it would be 19. For the third emission, the accumulator would be 19, and this would be 8, which would be the next emission. So it will add 19 and 8, which would be 27. Then for the next emission, 27 would be the accumulator. It would add that with 7, so we would have 34, and so on and so forth. So we can actually go through our list and yeah, have this accumulator value to basically add all items together, for example, or to do some other stuff with that. So if we actually now also make sure we print that here, and I'll actually decrease the starting value to 5, so we don't need to wait that long every time. And we launch this, then we can, oh, it says the count is, but doesn't matter here. Let's wait 5 seconds, and then it will print the count is 15. Because it actually now took all the values from 1 to 5 and added these up. So this is basically 1 plus 2 plus 3 plus 4 plus 5, and that is 15. And the same as reduce, we also have a function called fold, which is very similar. So we can use fold, and all that is different here is actually that we need to provide an initial value. So we can say that's 100, and then it will just start at 100 and then add these items from there on. So if we relaunch this, then wait 5 seconds, and we see, okay, now it actually took the 100 as a starting value and then added our 15 on top of that. So I think this is pretty clear and also not too hard to understand, I think. Okay, so far so good for the terminal operators. Now it's actually getting a little bit more complex when we get to flattening. You might also already know that from lists. So when we speak of flattening a list, that just means, if, let's say we have a list of lists. You just have a list, and like it has a list with 3 elements in it, then a list with 4 elements in it. And if we say we flatten this list, then we basically remove the lists in it, and we just want to have a single list with all the entries, if that makes sense. So maybe I'll just write a simple comment here. So we might have something like this, and 1, 2, 3. So that would be a big list of smaller lists. And if we want to flatten these lists, well, if we flatten these lists, then it would simply look like this. So we basically just remove the inner lists. And with flows, we have something very similar. So in flows, we don't really flatten lists. Instead, we flatten flows. So if we have 2 flows, then we can kind of combine these to have the results coming in a single flow. For that, I will actually not use our countdown timer because I think it's actually easier if we use a more simple flow here. Let's define that here, val flow, let's call it flow 1 maybe. And all that will do is it will emit 1, delay the coroutine for 500 milliseconds, and we emit 2. So very simple flow. And now we actually have a flow 2, which, yeah, I don't know, maybe emits something else. Yeah, let's actually not do that here. Let's create that flow inside of the function that I will show you now. Then it will get a little more clear. So what we can do is we can say flow1 dot flat map, and you can see we have 3 different versions of a flat map here: flat map concat, flat map latest, and flat map merge. So all these functions in the end do something very similar. Well, they basically flatten a flow or 2 flows. Let's start with flat map concat. So in here, you can see we get the integer value. This is triggered for every single emission from that flow. So here for that 1 and for that 2. And now this function, if we take a look here, needs to return a flow. So here, in here, we would now create our other flow that would emit something that can be based on the value of the first flow. So here we get the value, and we could say the second flow now emits the value plus 1, for example, delays for 500 milliseconds, and emits the value plus 2. And then if we say, okay, we collect this maybe, get the value in here, and we print the line, the value is value. So let's see actually what that does. Taking a look here in Lackner, and say the value is, and it prints the value is 2, which is, well, it is the first emission, which is 1. And now it will go inside of the second flow and add 1 on top of that. So we get 2 as the first emission. Then the second flow here will actually also emit value plus 2, which is 1 plus 2. So we get 3. Then the first flow will emit again. It will emit 2. And then it will go into this second flow, emit 2 plus 1, which is 3 again. And then 2 plus 2, which is 4. I know this is very abstract here. Let's actually think of a more practical use case of that. And that would be, let's say you have an app, a recipe app, in which you might cache some recipes. So there might be a remote API, and you might also have a local database in which you save your recipes. And as soon as you actually access these, then you get the result as a flow. So you might first get the recipes from your database, because that's just quick. Then you make the network call inside of the flow that the caching mechanism actually returns. And if you actually then get the result from the API, then you emit the actually up-to-date recipes that you get from the API. So that's how you actually get one recipe. However, if you now want to get multiple recipes and actually combine these emissions in a single flow, then you can use a flat map operator. So yeah, let's Let's try to simulate that here with the recipes I talked about. So let's say this would be a flow that just emits some IDs for recipes. So we could say 1 to 5 .as flow. So that's just a flow that will immediately emit the values 1 to 5. And then you could say flow1.flatMap concat. And in here you would say get recipe by ID. And you actually get the ID in here. So that would be a function that accesses your cache and returns a flow. And you just take all these emissions that come from this function and collect them here in a single block. But you don't just do that for a single recipe, instead you do it for 5 recipes. And you get all these emissions here in a single collector. So that is one use case you could actually use this flat map concat for. We also have a flat map merge operator, which is actually less used. And if you take a look at the documentation, I think it also says something like it's rarely used or should rather not be used. Here, note that even though this operator looks very familiar, we discourage its usage in regular application-specific flows, blah, blah, blah. So it's not that often used, but let's actually talk about the difference to flatmap concat. While flatmap concat will actually finish this flow's emission and then actually will go on with ID2, finish ID2 emissions, ID3, and so on. While on the other hand, flatmap merge will actually do all that at the same time. So it won't wait for the first emission to actually finish. It will directly launch the flows for ID 1, 2, 3, and so on. And then we have flatTab-latest, which is already, yeah, it sounds a little familiar to collectLatest, and it actually does the same thing. So if there is a flow that, like, let's say ID 2 actually finishes before ID 1, then it will simply drop ID 1 and only forward the result from ID 2 to the collect block. So it will only consider the latest one. So far for these flattening operators, I know this is quite hard to understand, especially if it comes to practical use cases. I hope this made some sense with these recipes here. However, I want to get to one more set of operators we have for flows. And I don't have a specific name for these, but these are basically all used to determine what happens with the emissions. So how are emissions forwarded? And for that, I actually want to create a flow here. And to make that a little bit easier, I will think of a real world scenario here. Like not in terms of coding, but in terms of something that you actually will know. And that is just ordering something at a restaurant. So let's say you're at a restaurant and you first want to order an appetizer, then you want to order your main dish, and then you want to order a dessert. Let's try to simulate that in a flow. We want to say, okay, we first delay that flow by 250 milliseconds, and then we say, okay, we emit the appetizer, because that's just the time it took to produce that for the restaurant. Then we can delay again, because now the restaurant is actually preparing the main dish. So we could say, okay, that maybe takes 1 second to finish. After that, we emit the main dish, and then let's say the dessert is just some ice cream that is already finished. So that's pretty quick. And we emit the dessert. So what we can now do with this is we can say flow onEach, and we first want to print, like that's now the string, which is either appetizer, main dish, or dessert. Want to print it is delivered. And I'll actually say, okay, if that comes in a flow, so we can just easily filter that in logcat. So we just get the info, okay, now the restaurant actually delivered that specific thing. And then we can say, okay, we collect the current dish. And we of course also need some time to actually eat that. So we can first say we print now eating it. So whatever we got, we're now eating that. Eating takes, let's say, 1.5 seconds. And then we want to have another print line statement after that that says flow finished eating it. And if we now actually launch that and make sure we filter that here for flow, clear logcat, then let's see what actually happens if we just leave it like that without any operators. So you see the appetizer is delivered, now eating appetizer, finish eating appetizer, main dish is delivered, now eating main dish, and so on. So if we don't do anything extra, then we do what pretty much every normal person in a restaurant would do is we eat the appetizer. When we finished eating the appetizer, we actually order the main dish. When we finished eating the main dish, we order the dessert and then simply eat that dessert. So what's happening here is all the suspending calls instead of this collect block like delay will also delay the flow here. So the flow will only go on with emitting values if our collect block actually finished. So if we finished eating our current dish, then the flow is ready to emit the next dish. However, there are other strategies for that. Strategy number 1 is actually called buffer. So what buffer will do is, that is a flow operator, which we can simply put in between here. What buffer will do is, it will actually make sure that this stuff runs in a different coroutine than this stuff. So let's actually try this out and see what happens, and then I will explain what happens. So appetizer is delivered. No, I can't even read that quickly. You can see it just runs through a little bit quicker than before. So let's go through it one by one. First, the appetizer is delivered, then we're eating the appetizer, but then the main dish is already delivered, even though we haven't even finished eating the appetizer. So now this flow will actually go on, even if the collector hasn't finished yet. So that would basically mean as soon as we get a specific dish, so as soon as we get the appetizer, we order the main dish. And we don't order it as soon as we finish the appetizer, instead as soon as we got the appetizer. But we will still eat all that in sequence. So we just get we just get the main dish and the dessert when we haven't even finished eating the appetizer. But when we do, then we simply go on with the main dish, and after that we simply go on with the dessert. However, there is a different strategy, which is number 2 here, and that is called conflate. So instead of buffer, we can say conflate. Let's launch that, and this is maybe not too obvious on the first glance. Let's wait until these emissions actually finished here. Okay, we finished eating the dessert. Let's go through it. So first of all, as usual, the appetizer is delivered. We eat the appetizer. Then the main dish and the dessert are actually delivered together, which was exactly the case like with buffer. So this is also launched in a separate coroutine, so the collector actually collects independently of this flow, of how this flow is emitting. And then let's take a look. Then we finished eating the appetizer, and then we're directly going to the dessert. So yeah, we basically completely skip the main dish here if we use conflate. So what conflate is actually doing, and what's the difference to buffer, if there are 2 emissions from the flow that we can't collect yet, like here, where the main dish is delivered and the dessert is delivered, but we're still eating the appetizer, we haven't finished eating it yet, then when we finish it, we will directly go to the latest emission, which is the dessert. So we will basically drop all emissions that came before the dessert, which is in this case just the main dish. So as soon as we finish the appetizer, we will directly go to the dessert and finish it, and we completely skip the main dish. And then there's actually also a third operator of these, which you already know, and that is collectLatest. So that will really only consider the latest emission. And yeah, let's try that. So instead of using conflate, we use collectLatest. Launch that and see how that would behave in this case. So we see appetizer delivered, eating appetizer, main dish is delivered, eating main dish, dessert delivered, eating dessert, and finish eating dessert. So the difference now is that we actually, as soon as we get the main dish, we stop eating the appetizer. You see, there is no line that says finished eating appetizer. And there's also no line that says finished eating main dish, because we're just so happy about the new dish that we directly eat it and throwing away the other one. So that is how collectLatest behaves in that way. Very complex and difficult to understand, I know. However, there will be a third video in this playlist in which I will talk about shared flow and state flow, which will be easier to understand, so definitely don't miss that. And as soon as that's out, you will be able to find it right here.